Okay, so we've got this container. It's the shape of this open right circular cone. It's shown in the figure above. The height's 10 centimeters and the diameter is 10, which means the radius is 5. Water in the container is evaporating so that its depth h is changing at a constant rate. That's key there. That's pretty important. In fact, that comes into play in part C. The fact that it's constant. What that means is that it doesn't matter what the height of the water is. The depth of the water is always going to be changing at -3/10 for all time in this cone. And this is just in this example. It doesn't have to be true for every example, but for this one it is. So -3/10 centimeters per hour. The volume of the cone of height h and radius r is given by the equation v equals 1/3 pi r squared times h. How many of you already feel like you got that memorized down? Okay, you should. The ones you need to not worry about memorizing are the volume of a cone, because they're going to give it to you like they did here. The volume of a cylinder, which would be the exact same formula, but minus the what? 1/3. And they will also probably give you the area formula for a sphere, or a volume formula for a sphere, or a weird surface area formula. Now, here's ones you are never given. You're never, ever, ever given any area formulas on the AP exam. You're only given volumes. So area of a circle, gotta know it. What's area of a circle? Pi r squared. Area of a trapezoid, gotta know it. Ooh, trapezoid. Area of a trapezoid. Do you know the area of a trapezoid? They did last hour. We'll get to that one. Area of square. Do you know the area of a square? It's just side squared. Area of a rectangle is base times height. Area of a triangle, 1/2 base times height. You even didn't know the area formula for an equilateral triangle, which I proved this year already once. And I said I was going to remind you of it, and I'm going to have to prove it again when we get to cross sections with integrals, and I will prove it again. But they don't ever give you area formulas. They give you volume formulas, but not area formulas. Okay? So with that said, they give you the volume formula. Part A, pretty simple problem, says find the volume of the container when h is 5. Indicate the units of measure here. So part A, okay, we've got volume is going to be equal to 1/3 pi r squared h, and they just want you to find the volume when h is equal to 5. This would probably be worth 1 or 2 points tops, probably 1 point, I imagine. Now there's only one thing in here that I think is fairly difficult to do, and that is you're not given what? Which one are you given? You're given height. What's height? Find the volume of the water in the container when h is equal to 5. What are you not given? You're not given the radius. You have to figure that out on your own. You have to figure out how the radius and the height are related. So since you have a right triangle at any height, it's r to h. And if you go to the whole triangle, that would be 5 to 10. So we know that the radius is always half of the height. Right? You can see that. And if you have to solve the proportion and go 10r is equal to 5h, and then say, or sorry, I did that wrong. 10r is equal to 5h, and then solve for r, you can see r is 1/2 h, or if you vice versa solve for h, you see h is 2r. Okay, so you should know how h and r are related. Okay, r is 1/2 h and h is 2r. Okay, so with that said, since we know the height is 5, what would the radius have to be? 2.5, but I'm going to do 5/2. Because without a calculator, it's always easier to do fractions, I think. Now, if you did decimals, that's fine. I'm just not going to check your answer right now. You're going to have to check it yourself. I'll tell you what the fraction answer and just compare it to your decimal answer. Okay, so what we're going to get then is we're going to get pi over 3 times 5/2. You just square the numerator and denominator, which would be what? 25/4. See how much easier it is to work with fractions. Times 5. So what I end up with is 125 pi over 12, and the units would be cubic centimeters. And by the way, this problem is worth, we can look at the rubric, I don't remember what it is. This is probably worth 1 to 2 points. So let's say it's 2 points. There is 1 point that doesn't even count for part A, B, and C, but it takes part A, B, and C combined, and it says you better get the units right for every part or you're going to lose a point. That's called the unit point. So you're going to get 1 point for the units, but it's only if you get the units right in part A, B, and C. And if you leave it off one place, you lose the whole point. Okay? So did we get the units right here? How many of you got 125 pi over 12? Now, if you got a decimal, here's how you check your decimal. Just take my 125 divided by 12 and see it's the same thing as your decimal that you got in front of the pi. Okay, so what's 125 divided by 12? That's 10.4. So you'd have about 10.416 pi. You wouldn't have it multiplied out by pi because you don't have a what? Calculator. So how many of you are agreeing with me? It's probably easier to do the fractions when you don't have a calculator. Okay? Especially if you start getting into crazy decimals, which that one was a little crazy. Okay, part B. Find the rate of change of what? Get alive, people. Y'all were like dead last hour. They're like so on the edge, peering in, and you guys are just like zombies right now. Okay? Doesn't even like go Teen Wolf on you or something. Okay, part B. Huh? We need a chili dog day, but I'm going to take it away if you guys don't get focused here. Alright? I'm planning chili dogs. When, next Thursday is what I got to do? Is that when you guys said I had to do it? Thursday, not Friday? Okay. dVdt. I'm after find the rate of change of the volume of the container with respect to time when h is 5. Indicate units of measure. We can do that. We want to find dV dt. That's the one we're after. When what? When h is 5. Okay? So, we got the equation that relates them already. 1/3 pi r squared. But let's talk about the variables a second. Does V change? Does V change? Yeah, because water's evaporating. V's changing. How much water's in the tank is changing because the water's leaving the tank. Which, by the way, we should expect this answer to be what? Negative because it's evaporating. Water's leaving the tank. Is R changing? As the water level goes down, will R change? Absolutely. But do you know dr dt? Do you want to know dr dt? So there is a dr dt, but I'm just not interested in it. So dr dt, you've got to eliminate it from the problem. Is there a dH dt? Yes, there is, and that's actually given. What is it given? It's -3/10. That was given in the directions. The rate of change for the height, the depth is changing at a constant rate of -3/10. So we got that one. That's good. So what one do we got to get rid of in this formula? R. What am I going to replace R with? 1/2 h. There we go. So we're going to have V is equal to 1/3 times pi times 1/2 h squared times h. So we're going to get V is going to be equal to, that's 1/4. That gets you pi over 12. So that's pi over 12, right? Is that right? 1/2 squared is 1/4. 1/4 times 1/3 is 1/12. So that'd be pi over 12 h to the third. Are we in agreement there? Okay, that's a simple equation to do the derivative of with respect to time. This is a problem. I'll let you know. That's 2. That's 3. This is probably be worth. Let's see. That's 3. 3. This will probably be worth 3 points as well. And I bet part C is worth 3 points, and that's how you get your 9 points. Every problem's always worth 9. Okay. So I'm going to do a derivative. It'd be dV dt is equal to 3 times pi over 12. 1/4 pi or pi over 4, however you want to write it. Times h to the second power. We did simple power rule. Now we're to the derivative of h. What's the derivative of h? dH dt. How many of you got that? I'm going to tell you where the points come from. You ready? The point came from you recognizing that you need to plug in 1/2 h. Listen, 1/2 h going in for R. Then the next point came from you taking the derivative correctly. You get 1 point for that sucker right there. What do you think the last point's from? Plugging it in and evaluating and actually figuring out dV dt. So we're going to have dV dt, here we go, dV dt is equal to pi over 4. What was h? 5 squared times dH dt, what's that? -3/10. And this is centimeters, so that's going to be centimeters squared. This is centimeters per hour, so you're going to have centimeters squared times centimeters per hour, which is going to be what? Cubic centimeters. Or you just think about it and say volume's always cubic times, and this problem is area squared. And you think of it and you go, oh, cubic centimeters per hour. Okay? So we're going to have, what do you get for the answer? I believe what you should get. Actually, I don't believe it. I know it to be true. It's -15 pi over 8 cubic centimeters per hour.
What happened to this 4 times?
All right, watch, guys. 25. 5 squared is what? 25. Let's see, that's 20. We'll change that into a 25. Then 5 goes into this twice. 5 goes into this 5 times. There's your 15, there's your 8.
Oh, we did 15 fours.
I love part
Sorry.
C. I love part C. This is a very, very
No, I told you.
in-depth problem where this, when it gets to part C, they get harder. Okay, part A, B, it's, and now if it goes part A through D, it's usually part A, B, and C are very, pretty straightforward. Here's the question. Part D, or the last part C, if it's a 3-part problem, part C, if it's a 4-part problem, part D, the last part is always a more in-depth kind of problem-solving, thinking, critical thinking type problem. Okay? So here's what it says in part C. It says show, so it wants to prove something. Jerks. Okay, show that the rate of change for volume. Now here's the key. I want to show that right there, the rate of change for volume. Rate of change for volume at a specific time or rate of change for volume for all time?
All time.
You know why it's for all time? Because they didn't give you a specific time. They didn't say when H equals 5. So they want you to show that the rate of change for volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. Now we'll get to that in a second. And then they want you to identify the constant of proportionality. And we talked about constant of proportionality yesterday. It's just saying if Canyon and Joe, they're not equal heights. One is bigger than the other. So we're going to say Joe is 1.3 times Canyon's height. Okay, so I just want to find out what that constant of proportionality is. If it's 1.3 for their height, what is it for this problem? So here's the deal. Watch. This is actually, you're going to be blown away at how actually easy this problem is if you know what it's asking. The key is finding out where to start. How many of you would agree that's the hardest part of the related rate stuff? Is that first step or two? Once you get, if I could show you step 1 or 2, how many of you could do every problem almost? Right? You can get to the point, once you get the equation, plus the differentiation, plug it in, it's off. Okay? Now this is more in depth because they want you to find the rate of change for volume. Do you see anywhere on the board where I know the rate of change for volume for all time?
Yes.
Where?
Constant rate. Oh no. Yeah.
Right there it is. You got it. You already found it. So when they ask you part C, you've already got on your paper what you need. It's just, do you know that you have it? Okay, show that the rate of change for volume. See this right here, once you found the derivative of volume, you found the rate of change for volume. This right here, it is it. This is the formula that calculates the rate of change for volume at any time. It's your derivative. So I want to show that that derivative, all right, this is where it gets fun. I want to show that dv dt, let's listen to it. I want to show that that is directly proportional to the exposed surface area of the water. So I want to show it's directly proportional. So it's some constant times the area, the surface area of the exposed water. Now what is the surface area of the exposed water? So it's some constant. So they're not equal. We're saying one's big constant. Remember yesterday we said, if you compare two people's height, they're not the same height.
Oh, so would the negative 3/10 be our constant?
We'll get to that in a second. Okay, so I want to show that 3/10 is going to come in, but not like you think it is. I want to show that the rate of change for volume is some number times the surface area. Now I think it's really important to understand what the surface area is. What's the exposed water? The top. What is that? So what's the area of a circle? So I need to show that the rate of change for volume is k times pi r squared. I need to show this. And then it wants me to find this constant proportionality. Like if Canyon's 1.3, or if Joe's 1.3 times taller than Canyon, or like in this example up here, here's the constant proportionality for radius and height. The radius is directly proportional to the height. It's 1/2 of the height. Or the height is directly proportional to the radius. The height is 2 times radius. Here, I want to show that the rate of change for volume is directly proportional to the surface area or the exposed surface area of the water. I want to figure out what that value is. So I need to make my formula. You already have dv dt. Well, what I need to do is I need to make it look like this. I need to make it look like a constant times pi r squared. I just need to do some magic. You ready? Let's do some magic. I got dv dt. Is that junk circled? You ready? It's way easier than you think. In fact, some of you are going to be kicking yourselves saying, why didn't I think to do that? Because you didn't know to start with this probably. But I bet I can get you there. dv dt is equal to pi over 4 h squared times dh dt. Now I want to somehow turn this into that, a constant times pi r squared. What's the first thing you notice that you have here that you don't have there?
R.
You have r. Can I fix that?
Change H.
I can change h back into what?
Yeah,
How
don't you
can-
need to do that before you take the derivative?
No, because we're trying to show that the derivative equals this. So we want to work with the derivative. We want to work right in the derivative. So what is h? 2r. So dv dt is equal to pi over 4 times 2r quantity squared times dh dt. Now, do we know dh dt?
Yeah.
Now, dHd could change based on different heights, but they told us it was what? That's why that was so important. Because it's always going to be negative 3/10, which means I can plug in for it. Now, watch what happens here. We're almost done. What's 2r quantity squared? 4r squared. What happens to the 4's? You get pi r squared times your negative 3/10. Guess what? You just showed that the rate of change for volume is directly proportional to the area, surface area. There's your surface area of the exposed water, pi r squared. There's your constant proportionality, negative 3/10. That's like, that ain't nothing yet. We're gonna go further after that. Is that cool? Now, nobody got C. I'm not even gonna ask because you
What if
did.
we got the proportionality constant right?
You would have got +1 out of 3. Go to. Isn't that cool? I think that's pretty legit. I'm gonna get you really excited now.
Do we get like